This is Padmaja from Institute of Aeronautical Engineering, Hyderabad. Now let us discuss today the user-defined functions and execute a number of programs using functions. Now, first of all, what do you mean by a function? In C language, functions are used to write a block of code for performing a single task or for performing any specific task. Now, the set of instructions which is used for doing a single task or specific task is enclosed by your parenthesis which does one particular task in a function. Now, whenever you want to divide the large code and you want to add modularity to your program, then function concepts or functional approach is the best approach. So, C provides the modularity concept through functions. Now, if you are using functions, then what are the advantages? The advantages are code reusability. That means you write the code once and use multiple times. Second, you can develop any application in modular format. So each module is going to do different tasks. So easy to debug. So whenever any particular module is not working, then you need to check the code only for that module. You need not check the entire program. So it will help you in easy debugging of your program. And you can also do code optimization. So no need to write the code multiple times and no need to write a lot of code. So use the modular approach using the concept of functions in C language. Now, coming to the types of function any programming language supports one is called the standard functions or library functions or predefined functions, and the other category is called user-defined functions. So a programming language normally provides a rich set of predefined functions or built-in functions, and user-defined functions we can write to carry out different tasks. So predefined functions or library functions and user-defined functions. So the major difference is predefined functions are a bunch of functions which comes through a number of header files or libraries in C programming. Whereas the user-defined functions are created by the user, and the advantage is it with the reduced complexity or reduced time complexity, we can develop these programs for different applications. Now, how to write a user-defined function? To write an user-defined function, we have to follow the particular syntax. First one is the return data type, followed by the function name and the list of arguments or parameters. So, here the return data type, if the function returns nothing, then you can write void. Void is a valid keyword which is used to write down, which is used for mentioning the return data type, and also which is used to mention the parameter list. So you can write over here, if the function returns nothing, then you can write down void a function. If it takes no arguments, then you can also write here void, and then you can write down the body of the function. This is called the body of the function. Now, if the function specifically returns any particular type of data, then you can change this to, suppose it returns integer, so you can write down integer, f1 is a function, and it takes no argument, so you can write down void, and then you can mention the body of the program. So this way the function definition is used, and the last statement, the default statement in any function is the return statement. If the function returns any value, then you write down return with some expression. If the function returns nothing, then you can use simple returns like this. So return statement, if you do not mention, then also the control by default returns to the calling program. So here the important things that you have to understand is how to write the return data type. So a function may return a value or a function may not return a value. If the function returns a value, write down what type of value it is returning. Based on that, you specify the data type. If it returns an integer, write int. If it returns a character, write char or float or double or anything. If it returns nothing, then mention it as void. Next is called the function name. Function names follows the rules of identifier. So you have to start the function name with alphanumeric, okay, and the first letter should contain one alphabet. So rules of identifier is applicable for writing the function name. Next is called the parameters. The list of arguments or parameters that is passed to a function. Okay. You can pass n number of arguments or parameters. If it takes nothing, then you can simply write void there. Or you can simply open the brace and close it, which indicates that it takes no parameters. Then you have to write down the function body to do a specific task. What do you mean by a function body? Function body is nothing but a collection of statements for carrying out or for executing a specific task. Now, if you will summarize it, then these are called the elements of a user-defined function. The elements are, first, you have to declare the function, or you can write down the function prototype. So, the function prototype indicates that this kind of function exists in your program. This is an information to the compiler that before going through the definition of the function or before executing the function, function prototype tells that the presence of the function in your program. So, next followed by function should be called. So there is a calling and caller relationship is there. So function must be called. And once the function execution is over, again the control must go to the calling function. And the function definition indicates that the function is doing what type of task and what are the statements inside the function and how to execute the function. Then the return statement indicates how to come back to the what that is the end of the function, and you have to go back to the calling function. So the major elements are function prototype declaration, then function calling, then function definition, and writing the return statement. Now, how to write down a function prototype? Function prototype is nothing but the process of telling the compiler that about a function, this kind of function exists in your program. So the function prototype follows the same type of syntax as the function definition. So it also takes the same return data type, same function name and list of arguments. But only the body of the function will not be there in a prototype. So the syntax is write down the return type followed by function name and the number of parameter it takes, and you have to end the prototype using a semicolon. As there is no body of the function prototype, so you have to write down a semicolon there. Okay. Suppose for example, int square int of a. That means the square is a function name which returns an integer and which takes one integer argument. This indicates the prototype. So while writing the function definition also, you have to follow the same syntax and attach a body to this function prototype to carry out how to find out the square of a integer. Then coming to the types of return statement, there are three ways to return the control to the calling function. First one is called writing the simple return. So the simple return doesn't return any value to the caller, but simply control goes to the caller. Okay. Then you can write down return with some expression. This return statement returns the value of the expression to the caller. And the third type, you can write return 0. If this type of return statements indicate that the program executed correctly and nothing is there to return. So only 0 is written, which indicates that it has executed successfully. Now, how to write a user-defined function in C language? To write a user-defined function in C language, 4 ways or 4 approaches are there for writing the user-defined function. The first one is called functions with no arguments and no return type. Okay. Second type is called functions with no arguments but with return type. Third way is called functions with arguments and no return type. And the fourth category is called functions with arguments and with return type. So there is no hard and fast rule which way you have to follow for a particular program. All the 4 ways are useful. So depending upon your need and application, you can follow any way for writing your user-defined function. So the last one, you can use it in most of the cases because most of the functions take some arguments and return some values, but there is no specific choice while writing the type of program there is no specific way that you have to follow this way. All the ways are allowed. You can write your program in any manner. Now, next is how the functions communicate with each other. That is called interfunction communication. So, there is always a communication that happens between the calling function with the called function. So, the calling and called function have to communicate with each other to exchange the information between one another. So, there are three ways of communication, and the process of exchanging information between calling and called function is known as interfunction communication concept. And for interfunction communication, either downward communication is possible or upward communication is possible. These two are called one-way communication. Okay, upward and downward communications are one-way communication. If you want to make two-way communication possible between calling and called function, then you have to go for bidirectional communication. So where calling and called both exchange some information. Now, next, coming to the parameter passing mechanisms in C language, there are two ways to pass parameters in functions. One is called there are two types of parameters available. One is called the actual parameter and formal parameter. And there are two methods to pass parameters from calling function to called function. One is called call by value or pass by value. Another one is called call by reference or pass by reference. So, what are the two types of parameters we are writing? One is called actual parameter and one is called formal parameter. So, the actual parameters are nothing but the parameters which are specified in the calling function. So, when that function is called, whatever the parameters you are passing, that is called the actual parameters. When the function receives those parameters, then it is called formal parameters. Now, we will understand this concept with the help of examples. Then, how to do the parameter passing, call by value and call by reference, how to use these mechanisms, we will check it. Now, first one is called the call by value mechanism. In this mechanism, the copy of the actual parameters are simply copied or passed to the formal parameters, and formal parameters receives and stores it in your separate variables. So, whatever the changes that you are making to the formal parameters doesn't affect the value of the actual parameter, because the actual parameter values are copied to another set of variables which is called the formal parameters, and the values are passed by the values are passed to the actual parameter to formal parameters. So both the set of parameters are different. Actual and formal parameters are two separate set of variables. So whenever you make any changes to the formal parameter, it doesn't affect the actual parameters. So once your task is over, the control comes back to the calling function where actual parameters are there, and you will see that there is no change in the actual parameters. Then the second mechanism is called call by reference mechanism. In this call by reference mechanism, we are using the concept of pointers. That means instead of passing the actual values, we will pass the address of the variables which contains the actual parameters. So the address of the variables that we are passing, so that any changes you do to that, then it is immediately reflected to the actual parameters. So this is called your call by reference mechanism. So in call by reference parameter passing mechanism, the address of the actual parameters are passed to the calling function or to the called function, and those are received by the formal parameters in terms of the pointers, that is called the addresses. So in that address, whatever changes you are making, that is reflected to the actual parameters. So the changes that is made to the formal parameters affects the value of the actual parameters. Now let us move on to our Deb C++ compiler and do a number of programs using functions. Now let us understand a program for converting a decimal number into binary. So the program is decimal to binary conversion using functions. Now, how to do a decimal to binary conversion? using function. Let us start writing hash include stdio.h. Then write down the structure of the main program. So int main, then return 0. Now decimal to binary conversion, for doing this, first of all you have to read a decimal number and we will write down a function for decimal to binary conversion and we will pass that number. So first of all declare a number int n and read that number. So printf, enter a decimal number. Enter a decimal number. So write printf and scanf statements. So scanf %d, then ampersand, the decimal number n. Now write down a function decimal to binary. Decimal to binary is the name of the function and there we are passing the variable n. So here n is a actual parameter. We are passing and decimal to binary is a function name which will convert the number into binary. Now this is called function calling also. We are calling the function decimal to binary and let us move on to writing the function. So this function returns nothing. So we will write on void. Name of the function is decimal to binary and it is receiving the value of n over here. So here n is a formal parameter. So the value of n is simply copied. So we are using the mechanism call by value. We are using the parameter passing mechanism call by value. Now let us understand how to do the conversion. So for doing the conversion, the number must be divided by 2 every time till the number is fully divisible, and we will store each and every remainder into an array. So let us declare an array of size 10 and we need one looping variable, suppose I is equal to 0. So first we will go for dividing the number by 2. So till the number not equals to 0, do the division process. So every time the remainder must be stored into the array. So a of I is equal to n modulus 2. N modulus 2 will give you the remainder and that remainder must be stored into the array. So first time I is equal to 0, the first remainder is stored into a of I. Then you change the number to n by 2, n is equal to n by 2 and then do I plus plus. So this is the logic for doing the division of the number. Till the number becomes 0, the process must go on. Now the array contains all the reminders, and whenever you are doing decimal to binary conversion, then all the reminders you must read from LSB to MSB, that is from least significant bit to most significant bit, which is nothing but in reverse order of the array we have to display the actual binary number. So how to read the array contents in reverse order? So let us write a for loop for I is equal to I minus 1 and till you reach to I is equal to 0. So I greater than equals to 0, do I minus minus. So while storing the reminders into the array, we have already reached to the end of the array. Now from the end of the array, we have to read it back. So we have written the logic for I is equal to I minus 1 till I greater than equals to 0 and I minus minus. And print it in the reverse order. So we'll write %d, comma a of I. Now printing the number in reverse order will give you the exact binary number. So let us write decimal to binary is the name of the program. Save it as a .c file. Okay. Now compile and run to check whether the program is working or not. Now there is no compilation errors. So enter a decimal number. Suppose the decimal number is 15 and its equivalent binary number is 1111. This is the correct output. Now, let us go for another test case. So, let us copy paste this output. Let us test it again with another test case. Suppose we are taking a number 10. Then it is 1010. The output is correct. So, like this, you can test for a number of test cases. You can write and then let us paste the output. Okay, like this. And this is our first program we have done from decimal to binary conversion using a function. Now, in this program, we have used the type of function. Type of function we have used is function with arguments. Function with argument and no return type. And we have used the parameter passing technique is call by value. So you need to understand how to call a function and then you need to understand how to write the program with different ways. So we have used here one way, function with argument and no return type, and call by value parameter passing mechanism. Right? So let us go for another program where we will convert a binary number into decimal. We will do the opposite conversion using another program. So the name of the program is binary to decimal conversion. First, let us write down the structure of the program. Hash include stdio.h followed by int main and return 0. Now, to do the binary to decimal conversion, what is required? So, we should know how many digits are there in a binary number. So, and then we will read the binary number. The number may be 4 digit, 5 digit, 10 digit, any digit binary number. So, for that, we must know how many digits are there in the binary number. For that, we have declared a variable n. Then looping variable I to read the binary number using a loop. Then let us take one array of size 10 to store the binary number into the array first. Then first you ask the user that how many digits binary number it is. How many digits are there? How many digits binary number you want to enter? Okay. Now this is nothing but the n value which indicates that the number of digits in the binary number. So ampersand n. After reading the number, then you have to, after reading the number of digits, you have to read the original number. Suppose n is equal to 4. That means there are 4 digits are there in this binary number. So read the 4 digits using a loop. So for I is equal to 0 till I less than n I plus plus. Then how to read the number? Scanf percentile d, then ampersand a of I. So we have read the number now. So after reading the number, call the function which will do binary to decimal conversion. So the name of the function is bin to decimal, suppose, and we have to pass the arguments n and the array. N tells you about how many digits are there in this binary number, and A is the array which contains the original binary number. So we have called the function. So let us write down the function. This function also returns nothing. So write down the declaration, your void bin to decimal and receives these arguments int n, comma, the array of size 10. So here you have to remember, you have to write down the same size of the array, otherwise you will get error. Now, after receiving both the arguments, that is the formal arguments now let us compute how to do the conversion process. So whenever you want to do the conversion process, you have to multiply each bit of the binary digit with 2 to the power of 0, 1, 2 and 3 and so on in reverse order. Okay. So for carrying out the multiplication and then summing up all the values, if you will sum it up, then you will get the decimal number. So how to do that process? So for that, let us take a variable. Initially I is equal to 0, which is a looping variable. Then we have to finally produce the sum. So sum is a variable and we have to do this process based on its position in right to left order. So I have taken three variables. One is for sum, one is for position, and for I is equal to 0. Now, for doing this process, let us take a loop. So for I is equal to 0, then till, or we have to read the array contents in reverse order, because it is from right to left, it should be multiplied. So I is equal to, let us take n minus 1 till I greater than equals to 0, and then I minus minus. So now we are trying to read the array from right to left. Okay. Now how to compute the sum? The sum is equal to the original sum, which is 0, plus. Now each bit from right to left should be multiplied by 2 to the power of position. So a of I should be multiplied with, we will use a function, power function. So 2 comma position. We have taken initially position is equal to 0. So first time the last bit will be multiplied with 2 to the power of 0. Then its next bit will be multiplied with 2 to the power of 1, and so on. So every time we have to increment the position. So position plus plus we have done. And then finally, when all the numbers are multiplied with their 2 to the power of 0, 1, 2, 3 and so on. When all the numbers are multiplied, the multiplication should be summed it up. That output is stored in sum, and that is the sum value is our actual decimal number. So what we will do here, we will print the decimal number which we are receiving through the sum variable. So it is nothing but the output of sum variable. So let us save this program as bin to decimal and save it as a .c file and compile and run it. When you have run this program, you got one error that is called the incompatible implicit declaration with built-in function power. So power function it is not recognizing because we didn't mention the header file. So write down #include math.h. So math function contains the power. Math library contains the power function. So we have to include the library, that is the header file. So after that, you can see that this function returns nothing. So ID returned 1, status is there. Okay. So we have written int main return 0. No problem. Undefined reference to bin to decimal. Let us check it once. Bin to decimal, here we have left one underscore. Okay. Now we have put it and see. Now there are no errors. So how many digits are there in your binary number? Suppose you will take a 4-digit number. Okay. So it is 1, 1, 1 and 1. And our decimal number is 15. So this is absolutely correct output that you are receiving through this program. Now we can copy paste this output. Similarly, you can check it for another test case. Let us take a 6-digit number. Suppose it is 1, 0, 1, 0, 1 and 1. So the equivalent decimal number is 43. This way, the function program should be done. Now, let us summarize that what type of function we have used over here for doing the binary to decimal conversion. We have used the function type as function with argument and no return type. So we have passed 2 arguments over here, but we are not returning any value. Okay. Now, what is the parameter passing technique? We are using call by value technique we are using. Now, let us do some small changes to this program. If you want to go for function with arguments and with return type, then what you have to do? Now, whenever you want to go for with return type, this print statement will remove here and will return the value of sum over here. So whenever we are returning the sum, then the function will not contain void, it will contain integer, because the return type is sum is an integer value. So write down there int. Now coming to your main program, you have to receive the sum value. So declare sum as a variable. In the function, you remove, okay. So declare sum as a function or result as a variable, sorry. Then you write down result is equal to bin to decimal n comma a. The result value we have to display it over here. So instead of writing here sum, we can write result over here. Now this way of writing is called function with argument and with return type. Now let us run this and check it whether it is working or not. Here we are asking first how many digits are there in the binary number. Suppose there are 5 digits are there. So enter the binary number 1, 0, 1, 1, 1 suppose. And the decimal equivalent is 23. So it is absolutely working fine. So this way the function can be modified in different ways. You can write with arguments, with return type, with arguments, no return type, and so on. In this video, we have understood the basic concepts of user-defined functions and how to write programs using function concepts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.